Hi, my name is Billy Rouse, and this is my Rube Goldberg today. The simple task is to buzz the buzzer. Let me explain how this works. First, the large ball hanging on string is pulled back where potential energy is being stored. When it's released, it swings forwards and hits the marble. This is an example of kinetic force when the ball touches the marble. Also, energy transfers to kinetic energy as large ball swings forward. This scene is an example of Newton's second law because when the big ball applies force on the marble gets launched forward because this has so much force and that has so much low mass. Now what happens next? The marble runs down an inclined plane, which is kinetic energy. The ball is pulled down the inclined plane by gravity. This is non-contact because the force is not touching the ball. The marble goes down a second inclined plane. 2. 3. The marble moves down its inclined plane using kinetic energy and gravity to be deposited into a funnel. 4. The marble comes down the funnel, which is non-contact force, because a force, which is gravity, is not touching the ball. The marble gets pulled down by gravity onto a third inclined plane and deposited into a second funnel. The marble transfers its energy to a larger ball at the top of this wedge, which is two pool cues with a blue thingy in the middle, which is sort of the wedge. Then contact force is seen when the marble hits the larger ball. As the larger ball runs down inclined wedge, that is kinetic energy. The ball hits a same size ball at the end of the inclined wedge, which is contact force. This sends the ball down to kinetic energy. The ball lands on a lever, which uses kinetic energy to send the opposite end of the lever up, pushing the matchbox car down to hit the Jenga pieces. The Jenga pieces are standing in a row, which is prior to contact energy. So all those Jenga pieces are having potential energy stored in them. Alright, the lever activates Jengas, which is kinetic force, and when the Jengas are in motion, they have kinetic energy. This uses Newton's third law because every action has an equal but opposite reaction. Jenga pieces continue to use contact force to knock each other down, but when they hit each other, they go back a bit. Alright, the final Jenga comes out in contact with the matchbox car. The resting car has potential energy. The car has wheel and axle as a simple machine. So right there is a simple machine. This is also Newton's first law because hitting the stationary car is at rest until acted upon a domino, which is the outside force. The car in motion stays in motion, displaying kinetic energy down an inclined plane to contact the spring-triggered matchbox car machine, which is what you're seeing now. As soon as the car contacts the trigger button, it releases a rubber band to set another matchbox car in motion with kinetic energy. The car, once again, is a wheel and axle. The car continues down an inclined plane, which is right down there, and displaying kinetic energy through a tube which hits Jenga pieces, which are stationary, and they have potential energy until acted upon the car. Newton's first law, this is Newton's first law, because the car uses contact force to push Jenga pieces down to ground using kinetic energy to hit the game show buzzer. Alright, let's start this off.